Hello, grade 11s. For our review today, we're going to go over what you need to know for your exam. To do that, you need to know how to evaluate absolute value expressions, solve, and graph. So here's an example of evaluating. So when we evaluate, make sure you just use BEDMAS. So I'm going to start in here in the brackets, negative 12, and I'm going to go to my next bracket, that is 5 subtract 8, and I'm going to go to my next bracket, which is minus 7 plus 1, so that's minus 6, minus 4 more. Okay, when we keep going, this 5 minus 8 becomes negative 3, and the minus 6 minus 4 becomes negative 10. So now I've done everything I can in the brackets, which means I can take it out of the brackets. So that's going to become positive 12, subtract positive 3, plus positive 10, and then we can just finish that off with some subtracting and some adding. So 12 subtract 3 is 9, plus 10 equals 19. Next question. Pause the video if you need more time. Alright, so the next one we're going to graph. The function we're going to graph is f of x equals absolute value of x minus 3. So I hope that you're thinking that this is going to look like a V, and that's because it starts as a line. So when we graph this, we're going to start by thinking mx plus b. So it's going to start at a y-intercept of negative 3, and it has a slope of 1, which means I'm going to rise 1 and run 1, rise 1 and run 1, rise 1 and run 1. So we've got this line of y equals x minus 3. But since it's absolute value, we can't have the part of the graph here go into the negative. So I'm going to take that negative 3 and I'm going to reflect it up. So now it's at positive 3. And then just finish the V shape from there. Now that would be the graph of the absolute value function. Be sure your x and y intercepts are correct because I'm going to be picky about those points. Now we determine the piecewise function. So when we figure out the piecewise, we say y equals, and we do a big curly bracket. Now I'm going to start here with the original part of the graph, which is in blue. Now the original part of the graph is called x minus 3, because that was the original equation that I started with. And the original part happens from 3 bigger. So we say if x is greater than or equal to 3. Then I have to look at my flipped part of my graph. This was done in green. Now the flipped part of the graph, we put a negative in front because a negative means that it flipped. Now we say the flipped part happened where x is less than 3 because it starts at 3 here and it goes downwards from 3 or smaller. So that would be called a piecewise function. Now finally, we have to state domain and range of this graph. So remember domain, we talk about how wide does it get. Now this graph looks to me like it goes on forever in both directions wider, so we say that x is an element of reals. It gets wider both ways. But the range starts here at the vertex of the V and goes up. So we say that the y's are all greater than or equal to 0 because they start at 0 and go up from there. All right, pause if you need more time, and I'm going to move on to the next question. Okay, next here we have a solving question. So remember that when we're solving, you need to solve with 2 cases. And the reason you do that is because you need to hit each side of the V-shaped graph. So when we do case 1 is where we take the positive part of the absolute value. So at 1 minus 2x, remember the original didn't change, so we keep 1 minus 2x. Now we just set that equal to 9. Case 2 is where we take the flipped part of the graph. So to represent flip, I'm going to put a negative out in front. So it's negative 1 minus 2x equals 9. So again, the flipped part has to have that negative. And then we just go through and solve both sides. So here I'm going to subtract the 1 over, so we get negative 2x equals positive 8. divide out the negative 2, so we get x equals negative 4 for one of my answers. On the other side, we're going to have to distribute that negative into the brackets to make sure it hits both parts. And then we're going to add that 1 over. So we have 2x equals 10. I'm going to divide out that 2, so x equals 5. So there it looks like I have two answers, but you have to check because sometimes you'll have roots that are extraneous. So I'm going to take that negative 4 and I'm going to plug it in for the x in the original equation. So this is going to give me 1 minus 2 times minus 4 is positive 8. So 1 plus 8. And the absolute value of 1 plus 8 is 9, which does equal 9. So I know that negative 4 is one of my answers. Now I'm going to do the same thing, but I'm going to plug in 5. So I'm just going to change my values here. Instead, I'm going to plug in a 5. So now we have 1 subtract 2 times 5. So 1 subtract 10, which ends up giving me a negative 9. Now, is the absolute value of negative 9 equal to 9? Yes, it is. So that means x minus 5 is one of my answers as well. So we have two answers for this problem. Now we're going to move on to the next one. All right, now we're going to graph a absolute value function that's originally quadratic. So in order to do that, we still have to find our x and our y intercepts. So to find our x intercepts, let's start by factoring this guy. So when we factor it, I'm going to put the 3x and the x in the front. 2 is 2 times 1, so I'm going to put a 2 and a 1 in back. And I'm just going to make sure when I FOIL it that it works. And yes, it does. So that tells me that I have two x-intercepts. One of them's at negative 1/3, and the other one's at negative 2. So I have two different x-intercepts. Now when I look at the y-intercept, remember that the y-intercept is always that constant. So I already know that my graph is going to have some of those key points. So a y-intercept at 2, x-intercepts at negative 1/3, and negative 2. Now, I know that my vertex is going to be kind of somewhere in here, but I need to figure out exactly what that vertex is. So I'm going to start by going negative b over 2a, which in this case is negative 7 over 6. Or if I change that into a decimal to make some of you happy, that's a negative 1.2 approximately. So when I know that the x value of my vertex is at negative 1.2, now I need to find the y value. So to find the y value, we're going to plug that negative 1.2 back in to my equation. I've already done all the work here. So when you plug that in, you're going to get approximately negative 2.2. So I know my vertex is going to be down here at a negative 1.2 and negative 2.2. So my original parabola looks something like this. But this is an absolute value parabola. So we have to make sure we take that part that was in the negatives and reflect it up. So now that vertex is actually going to be a negative 1.2 and a positive 2.2. So this point, negative 1.2 and positive 2.2. Again, you have to make sure that that x, y intercept and your vertex are all correct when you're graphing these. So now we have the graph. Now we just need to create the piecewise. So when I look at the piecewise, I see that the original piece, so 3x squared plus 7x plus 2, is the black parts of the graph. So I'm going to say if x is greater than or equal to negative 1.3, or 1/3, sorry, because that is where this one value is. And then I'm going to say that it's also where x is less than or equal to negative 2, because that's where my other x-intercept is. Now we have to look at the blue part. So the blue part is flipped. So I'm going to put a negative in front. to show that it flipped. And the flipped part is happening in between these two x-intercepts. So we're going to say that x is in between -2 and -1/3 for your piecewise. Domain and range are going to be the same as before because your domain still gets wider forever and your range still starts at 0 and goes up. So those are still your domain and range. Now again, pause the video if you need to, and we're going to then try these questions in your textbook. Good luck.